Yeah, so this is Adventures in High Performance Logging. My name is Ryan Resella. I am a senior software engineer at change.org. I'm based in Los Angeles, California, where it is currently very smoky. There's a lot of wildfires going on here in California. I also live with my corgi roommate here. She's trying to code, but her arms can't really reach the keyboard often, so gotta help her a little bit there. So a little bit about me before we dive into this talk. In 2011, I was at Code for America in San Francisco. I was an inaugural fellow, and I was also the organization's first tech lead. In 2012, I joined Obama's re-election campaign as a software engineer, working there in Chicago. And then after the campaign ended in 2013, I joined Upworthy when it was just 11 months old, and I was the fourth engineer there. If you read my bio, I don't know who reads bios. I think most of us do to get a sense of the talk. You might have seen that I'm a bit of a competitive cyclist here. And so I race bicycles on both the road and the velodrome. I'm an amateur. I'm not a professional. I do it as, like, I tell people the sport I play. Some people play like soccer, or I guess American football, however you want to say it. I race bikes as my sport. And so over the years, I've won 3 state championships over 2 disciplines on the road and the track. I've also won several second place finishes, and I've also competed on both the world level and the national level on the track. And so I work at change.org, and the interesting thing here about this virtual conference is I had all these prompts and kind of questions for the audience. So the funny thing is, since I can't really see most of you, or this isn't that interactive, I just can skip some of these. So the question here, though, is, who here has heard about change.org? And maybe just, it looks like a few of you actually. Okay, great, that's awesome. Okay, cool. So if you haven't heard about us, we are, in simple terms, we are the world's largest platform for change. And we are a public benefit corporation, and this is our vision and mission for the company and kind of for the world here. And so our vision is a world where no one is powerless and creating change is part of everyday life. And the mission is to empower people everywhere to create the change they want to see. And so some people might ask, how does that manifest itself in creating change here? And so we do this through campaigns. And what that means is anyone can create a campaign about almost anything, and then anyone can go to change.org and support these campaigns. And so here are a few examples of campaigns that are currently on our platform. So you have the UPS, another one with renaming the bridge here, and then this victory here at the end. So we see a wide variety of campaigns on serious topics, and then we also have some ones that are kind of fun. So you see this kind of like wide range in different petitions on our website. And so every day we see victories through our campaigns. And the one here on the right is an example of a victory where these 2 girls petitioned Starbucks to make a better cup, and Starbucks changed the way they make their cups to be more environmentally friendly. One of my favorite petitions I've seen on our site is this petition to rewrite Game of Thrones, the season 8 episode. So if you're not familiar with the show, then probably doesn't apply, but if you could have mixed feelings about the last season. Over 1.8 million people signed it. Maybe one day we'll achieve victory, yet to be seen. But it did cause the HBO producers or higher up levels to kind of respond to this petition, because there are 1.8 million people who signed it, and it got like a lot of popularity. So that's a little bit about change. Like I said, I work on our email platform, and so we send about 1 billion emails a month. In 2018, we migrated from this big email vendor. It like sold the force, if you're familiar with them. This custom email platform is built in Elixir, and then now we have Elixir adoption throughout our organization. So Elixir is one of our 2 primary backend languages. The other one is Ruby, just in case you're wondering. So this morning for me, it's 9:47 a.m. here, pretty late if you're in Europe. And I'm also between the snack break, so I know that's always the barrier. Like you never want to do a conference talk before lunch because everyone's like hungry or after lunch. So I know I'm in between here. So we'll try to get through this. So I'm going to be talking today about everyone's favorite subject, which is logging. And this is the adventures in high performance. So as we go through this, I'm going to walk you through this adventure. I'm going to start with this brief intro into Kinesis, if you're not familiar with it, some stories about Logger and disk log, and then how we create this custom GenStage pipeline to finish this off. And so, like I said, we send a lot of emails. And the question is, how do we get billions of records into our data warehouse? And so each email we send, it generates several events that we need to log. When I worked at Upworthy, you saw a lot of headlines, and now you probably see a lot of emails from change.org. So if you're not familiar with Kinesis, it's a Amazon product, and there's a couple different layers, but we use the Kinesis data fire hose. And what this does is it provides a way to load a bunch of events from different data sources. It's high availability. And then once that fire hose ingests, it can move that data to places like Amazon S3, Redshift, Elasticsearch, and Splunk, and then you can consume it and change the data however you want from there. But that's how we get our data from into our data warehouse. And so there's two different ways of interacting with the Kinesis data fire hose. There is the Kinesis agent, which is a pre-built Java application that runs on the server. And it's a daemon that monitors certain files, and then it sends that data to Kinesis. And then the second one is the Kinesis API. So what we're going to do first here is go. We're gonna try using the Kinesis agent in this first one, since that's probably the simplest way. We don't have to deal with the API. We can just we'll try the agent first. So this is kind of how it illustrates. This agent reads from this log file. The agent will then push that data to the fire hose. And so now we just have to figure out how to get our events to a log file, right? And so let's dive into stage one here. The Tour de France is currently going on right now. Usually happens in July, but this year, obviously, it didn't start in July. And so it takes place over 23 days. There are 21 stages and 2 rest days. Luckily for us, this talk only has 3 stages. And I think they're on the stage 13 today, probably. It just finished this morning. I didn't see, or the stage finished. I didn't see who won yet. So no spoilers. I'll probably watch it a bit after this. And so the first thing we do, or we're going to talk about here for stage one, is the logger module, right? And so the logger module, it's part of Elixir. It provides us different logging levels, and it supports multiple backends, but it defaults to the console. And so it switches between async mode and synchronous mode to maintain performance. So we use the logger module to log our events to a file. Kinesis agent then picks up those events in the log file, and then the Kinesis agent sends it off to the Kinesis fire hose. And so this is the diagram illustrating this. Our app at the top here is emitting these different events. And then our events are being captured by logger to a log file. Kinesis agent reads the log file, and then off to the data fire hose it goes. And then we can process those events later downstream. So problem solved, right? Great, we got our data to Kinesis. Well, not really. So the question here is, what happens to logger when you overload it with data? And I'm going to see in the chat here if anyone actually knows this answer. Someone might know. Okay, I'm not seeing if anyone knows this. I'm sure someone does know this, but I'm just going to reveal what happens. And so if you had it overflows the logger queue, you won this stage. So what happens when you start overflowing the logger queue? And it slides back, it says that logger switches from async mode to sync mode to stay performant. Well, so when you're overflowing the logger queue, you're now in sync mode. And what this does is it starts to slow down the app. And if you're a web app, that means requests are going to be slowed down. And then for us, it means that emails will either stop, slow down, or not be sent at all. And so here are the Elixir docs that highlight this. And so we tried tuning this by turning the sync threshold to a higher number. And then we started trying to put the discard threshold to a higher number. So the amount of, so when it would the amount of messages that would go through the system to not switch over to sync mode, and then the messages to not discard. And so we didn't have a good testing structure for this. And at no point where we wanted it to ever, we wanted our system to ever switch to sync mode. And we never wanted to discard the messages. So at this point, there was really no good kind of adjustment here that we could do. And so obviously this is not performance. When you have a back pressure driven system, it slows to a halt. And so for your cycling fans here, you can end up like Chris Froome. He's wearing the leader's yellow jersey for the Tour de France. He's running up Mount Ventoux without his bike because he's trying to win the race. And so let's take a look at this problem again, right? And so we still have the same problem. We need the Kinesis agent to read from a log file. And we need that Kinesis agent to push the data fire hose. And so we're still in the same problem. How do we get our events to a log file so the Kinesis agent can read it? And so let's move on to stage 2 here, which is the disk log. So what is the disk log? If you spend some time Googling this, you might not find a lot of information online. There's a very nice looking man page, and there's a handful of blog posts and talks about disk log. But for those of you who have worked in Erlang might already know what disk log is. It's part of Erlang, and it efficiently writes logs to a disk. And so how efficient are we talking about? It handles about 100,000 writes per second. And so looking at our app diagram here, again, it's the same thing. So we have our application emitting these events, and we're still using the Kinesis agent, but instead of using logger, we're now writing to the log file using disk log. So great, problem solved again. And I think everyone knows at this point, since this has 3-stage talk, this obviously is not the winner here. So this did not solve our problems. It got us to a bit, but more problems kept up, obviously. And so what could go wrong when you're writing billions of logs to events, log events to the disk, right? It looks like these cyclists might know. You kind of get bottlenecked here, and then you start discarding events. The cyclists have nowhere to go here, so they're off the road. So yeah, we had a lot of problems using disk log in just a different way than logger, and so they manifested themselves slightly differently. So now we have this high volume of data, and since the events aren't being discarded, we're not losing them. We're writing all the events. The log files on the instance started to fill the disk. And then this wasn't a disk log problem. It worked so well. It was so efficient that we started running out of disk space. And so we even started building our Amazon EC2 instances with bigger hard drives to kind of alleviate this. So after that, we started doing log rotation. And so there's a couple of different things that happen when you rotate the logs. You lose data when the file handler would stay the same. When you restart, you have to restart the application after rotating the logs. And then we would also drop data or repeat the data during this time. And so this is how we kind of illustrate it. So before log rotate, our application would write to this log file using disk log. Kinesis agent would pick up the Kinesis agent reads that log file, and then the log files would just fill up the instance here. And so we started rotating the logs, and so the old log file would get compressed to save disk space, but then the application would still be pointing at the old file handler. And the Kinesis agent is still reading from the new log file. And so now we're not getting data into our Kinesis agent, and the application is still pointing to the old file handler. So what we did here is we had to do an app restart. This restart released the file handler lock. And then now the app is writing to the new log file. Kinesis agent is reading from the correct log file. But during this time, when we were rotating the logs, we're going to drop the data or we'd start duplicating the data. So that caused a bit of an issue. And so a little bit taking a step back here and trying to see how we could solve this problem that we were having. So we lived in this current state of disk log for a while, and we probably could have stayed there. And there are a couple different things that we didn't want to do, obviously, by losing data or duplicating the data, because we want this to be high performant and get the correct data that we need. And also getting paged in the middle of the night to log in and go into the instances and delete old log files isn't fun. You want to kind of never get paged and not get paged in the middle of the night. And so that wasn't always a fun experience. And so when we looked at kind of the troubles that we had, it made the biggest thing here is it made debugging data problems difficult. So we didn't know if it was an issue with the application, the log files. It could have been an issue with the Kinesis agent. And so troubleshooting and debugging there made it very difficult. And then we had this data loss and duplication that I've talked about a few times. And we definitely do not want data loss, and we definitely do not want to duplicate the data. So Jose here suggested that maybe we should start writing to the Kinesis API directly. Obviously, this is pre-pandemic. No one's wearing masks, no social distancing. So we gave this a try. Let's see what it would take to write to the Kinesis API directly. Before I showed you that there were two different ways to write to the Kinesis API. At the time, we picked the Kinesis agent because that was the easiest way to get us to what we needed to do by writing log files. So let's look at what it would take to use the API instead of the Kinesis agent. So the API has two operations to get it into the Kinesis firehose. You have put record for a single record, and then you have put record batch for a batch of records. And so now we have kind of a different problem to solve here. The old problem was writing to a log file so the agent could pick it up and then sending it off to the firehose. So now we have to figure out how can we write to the Kinesis API instead of writing to log files. And so before we dive into this final part, there are a lot of tools available in Elixir and the Bean. And we tried all of these, or those two, and we pushed them to the limits. So this is kind of before you decide to build a third party, before you do the thing that I'm about to tell you not to do, we tried to see what we could use that was there for us already. And then now we built this. So we exhausted and we hit the limits, and now we're off to this final stage. And so this is our final stage of Kinesis Hydrant. Like I said, there's 21 stages in the Tour de France. The final day always ends in Paris. It's mostly, if you watch bicycle racing, it's like kind of ceremonial. The winner is usually determined before the race, before they get to Paris. And the leader always wears this yellow jersey, and they ride into Paris drinking champagne, and then they do laps around the Champs-Élysées. And so this is Justin Almeida here. He is a staff software engineer on our comms team, and he's the one who built this. And so Justin here is ready to ride into Paris. These are the few libraries that are used in this Kinesis Hydrant. XAWS, which we all use. It's the interface for interacting with Amazon. For this, we used it for S3 and the Kinesis Firehose. And then we use GenStage. And so this is the stepper that sends and or receives data from the other stages. And so just kind of a reminder, this is part of some of the process of how we were thinking of how do we get rid of these problems or fix these problems so we don't have to deal with them in the future or make it a little bit easier. So debugging, duplication data, data loss, error handling. The Kinesis Hydrant helps us solve these problems, right? And again, this is what the Kinesis agent setup looked like. We had our app here emitting the events, writing to log files, the Kinesis agent picking up the data from these log files and then setting it off to Kinesis. And so now this is what our Hydrant setup looks like. And so, like I said, we process about 250 million records a day because each email we send, we track a number of different events. And so what the Kinesis Hydrant is, it's this funnel that you dump data into, and it shoots off the API request as fast as possible. So your app pushes events onto the hydrant. The hydrant emits cast events, and then events are batched and sent to the Kinesis firehose using put record batch function in the API. And so these are the internal. So let me go back one slide. We're looking at the bottom portion now where it says hydrant. This is the internal workings of this. And so this is a subfunnel using subfunnel or pipeline using GenStage. The pipeline has one producer and n amount of consumers. So think of this very similar to Broadway. Our events get pushed onto the hydrant from the app, and then they start to batch. And so once we reach that batch limit, we send that batch to the Kinesis API, and it's a configurable level, so we can decide how many we want in the batch. If we don't hit the batch, we have also a configurable timeout. And so if the batch level is not reached and the timeout hits first, then we send that batch off to the Kinesis API. And in the end, we're writing to this delivery stream API provided by Amazon Kinesis. So there's also error handling here. And if the batch fails to send to the Kinesis firehose API, we write it to a local failure log. And then the hydrant goes back and reads from this failure log and tries to resend the batches. So that data loss that we were talking about isn't happening anymore because we're retrying the batches. And now if we have, there's an option to enable S3 here. And so we can also, instead of writing, we'll write to the log instance on the disk, but it's a configurable level. So we can also write it to S3 as another storage mechanism. So we have the data that we need and we're not losing it. And then shutdown, we want to gracefully shut this down. And the first part, as we go through this, is the batcher shuts down first. Any of these existing batches are then flushed to disk. This shutdown will then cancel all the consumers. The consumer supervisor is then shut down. And the last thing we do is we take the error handler, and that one's shut down last. And once that is shut down, the logs are synced. And again, if we're configured, it'll push to S3. So the question that some people might ask, like I mentioned Broadway, why didn't we use Broadway, or why didn't we use Flow for this? Well, when this was built, Broadway was not yet released. And we're pretty close to completing Hydrant here. So we didn't want to make this switch quite yet. Also, the batching functionality has minimal benefit here because the Hydrant just uses one single batcher. And we also just have this two-stage topology. So there's only really quite two stages. And so it seemed a little unnecessary to move us to Broadway here. And at the time, Broadway was meant to be a pull-based system with a producer. I'm not quite sure if that's still the case. I think there's arguments for both. It could still be a push. So here, so there in Broadway, the events are pulled. Hydrant is a push-based system. So when the events come into the Hydrant, we push them off to Kinesis. And similar argument where it could be a pull-based system, but the way we wanted to do it and the way we wanted to get the data in, we use it as a push mechanism. And so there we go. Our problem is actually solved at this point. The problem of how do we get billions of records into our data warehouse? And so this solution was great for us. Our data counts started to go up. We stopped losing the data. We stopped duplicating data. And we started to use Hydrant in multiple services. So we started with one of our comm services, and then we were able to use it across the other services in our email platform. And then we started changing it so we can actually use it for multiple third-party sources. So right now we have our particular email agent, and then we're going to start doing text messaging soon, and that's a different vendor. And so we'll be able to receive data from each of those, because before it was really specific for that one vendor. And then we also took this batcher idea, and we started using it in different cases. And so we batch, before we insert to the database now, we do batches and then we insert. So we aren't constantly just writing single records to our database. So yeah, now we can finally go and do victory laps around the Champs-Élysées and then don our race winner's yellow jersey on the podium in Paris. And this is a plug for our recruiting team here. We are hiring. There are a few openings, so just go to change.org.careers and check it out. I think I'm like right at time here, so we are at questions.
Okay, so I have opened the session's question and answers. If you want to make a question, I have a question that you talk about you developed the part of the hydrant.
Sorry, what was the question again?
Did you develop the hydrant part that was connected to the Kinesis API?
The part that was connected to the Kinesis API.
Hydrant. In the slides, you put the box of hydrant that is inside of your box, inside of your infrastructure, right?
Yeah, here, let me see if we can find the one we're talking about. This one or?
Yeah, that one. So as I understood, you told that that is part that is connected to Logger and is pushing the information to Firehouse.
I see. So yeah, so here we're no longer using Logger or disk log. So at this point, with the Hydrant, we use the Hydrant library has a push, and so we tell the Hydrant, we do like the function is just .push, and so we do Hydrant push with the event, which is normally like a tuple or a map, and from there it does a GenStage cast, and then the next part of the GenStage picks up is reading from cast and then picks it up from there.
Have you open sourced that?
So that is a spectacular question. We have not quite open sourced it yet. We do plan on in the future. It was built in a way that could be open sourced, but there needs to be some small adjustments because there are specific things that are just pointed like at our own services or our own configurations. So it just needs a little bit of cleanup, but it was created in a way to be open source. So we will open source it one day.
Okay. Did you make some specific benchmark with the old one to know how times is better than the usual configuration of Logger?
Yeah, so that's a good question too. So our benchmark really was based on the data. And so we could test, we have like test audiences, and we could tell typically we would lose X amount of events, 2 or 3%, sometimes higher. And the way that we could tell is, let's say we send 1,000 emails and the data we're receiving back from our mail provider only tells us that we sent 80. So that's like an absurd amount of numbers, obviously, but we could see that the numbers weren't matching up. We knew that we sent out this amount of our system, but then the mail provider is only reporting it back. And so basically our key result numbers, our data numbers of sends or unsubscribes, clicks, opens, they started to balance out better. So it looked like what we were seeing, what we should be seeing based on numbers that we had on our old email system.
Great. About the infrastructure, you say that you are developing the output for the emails. Are you using some specific library to use the SMTP to send the emails, or you are developing your own?
So we have a mail provider. We have they're called MTAs, the mail transfer agent. We use a third-party provider, email is a very strange thing. So in many ways, email is is built, a long time ago. And in a lot of ways it's the same. And and a lot of email is prevented to stop spam these days. And so there's just a number of different algorithms. There's a number of different things that companies like Gmail or Google, Microsoft, Yahoo look at. And it's all about reputation and IPs and just a number of different things. And so we use a third-party provider, our MTA mail transfer agent, to actually send the emails. So we're not sending them through like our own SMTP relay on AWS or anything. It goes through this provider who has like a reputation and can kind of adjust their either IPs or whatever needs to happen to make sure that the emails are still they'll get stuck in spam, basically.
Mm-hmm. About the scaling, because I know that when the change is opened for some specific campaign or that is very viral and you have some specific peaks, how do you handle or how do you deal with the specific peaks in your platform?
Yeah, that's a good question too. So I can speak for two different things here. So on the main change.org website, it's built in a way to handle these kind of peaks because things can happen, events happen in the world, and petitions can gain traction at different times. And so we have a very good team. Our infrastructure team and our engineers it's built in a way to handle these massive traffic spikes. For us, we have on the email platform team, we have a bunch of different ways to handle this because we send in lists and segments. We very rarely do an email where we send it to all our users. And so if we do, we kind of we know that that's going to happen. And it's a queue-based system, and it's back pressured. So a lot of it is we drop it. Our message will start in a queue, go through a number of different processes, and then go to the next queue, and then go through like a number of different processes. So it's really just using Elixir to kind of process these emails and these spikes. And it's a worker. It has to churn through these. So just imagine like these different queues filling up, draining, filling up, draining, filling up, draining, and they're meant to have high volume of emails for the kind of volume that we send.
Okay, connecting with the next question, what's the max throughput that you have at the moment, and how many instances processes and either on consumers are you using for that throughput?
That's a good question. So I would have to get back to you on this one. I don't actually know this max throughput since we batch. So for the hydrant, we batch. And so the throughput could be different because the way we send emails is it goes out like in a blast, and they're basically chunked. So like email goes out, and then we receive a bunch of events at the same time, and a bunch of people will get it delivered and open, but then not everyone's checking their email all the time. So the initial one will have like a bunch of events, and then it'll slow down and you'll see them trickle in slowly. So I'll follow up on that one. Let me just switch to my contact info here really quick so that way I can follow on this. I'm not sure the exact max throughput though. And then the second question on here is how many instances processes hydrant consumers are using for the throughput also. I'm not exactly sure on that one too. I'll have to follow up.